In this video, we will demonstrate the operation of the cable tray and conduit selection module of the Sizer Electric software. We will describe the process for sizing cable trays and conduit systems, which consists of three main steps. First, enter and calculate the circuits in your project. We recommend watching the conductor selection video. Also review the information in the standards section. Second, create a tray or conduit cross-section. Third, assign circuits to the tray or conduit to calculate the conductor areas and, based on those results, select the appropriate tray width or conduit diameter. Finally, we will generate and print various reports. Standards review. First, let us review the information in the standards section. To do this, select Queries from the main menu, then choose Standards. Or click directly on the Standards icon on the toolbar. This opens the main Standards window. Select the Conduits and Cable Trays tab. Define the required fill factor for cable trays and conduits. For example, if the project specifications require a 20% spare capacity, set the fill factor to 80%. This allows trays to be filled up to 80%, leaving 20% available for future expansion. This fill factor can be modified later for each individual tray or conduit. The value defined here is simply the default value used in the tray data entry windows. Although electrical codes and standards allow a wide range of cable tray widths, project specifications often limit the minimum and maximum allowable widths. For example, a minimum width of 150 mm and a maximum width of 900 mm. To define the tray widths and the minimum and maximum values used in the project, use the list labeled Cable Trays. This list contains 4 columns. The first column, Use, enables or disables a tray width during the calculation process. Disable tray widths that are not commercially available in your region. The second column displays the tray width. The third and fourth columns, Min and Max, define the minimum width at which tray selection begins and the maximum tray width allowed. To change the minimum tray width, click on the corresponding row to reposition the red arrow. Repeat the process for the maximum width column. A similar condition applies to conduit. In this section, select the minimum conduit diameter that the software may select and the maximum conduit diameter allowed in the project. When selecting the cable tray width, the code allows either a single common equipment grounding conductor, size to the largest conductor in the group with taps to each circuit, or one equipment grounding conductor per circuit. The first option applies a single common grounding conductor for all circuits in the tray, while the second option assigns one grounding conductor per circuit, which increases the required tray width. The checkbox, Inherit Circuits in Nested Trays, allows, in the Circuit Assignment to Trays section, a tray placed inside another tray to automatically inherit the conductors from the parent tray. This significantly reduces circuit assignment time and is especially useful for tray expansions or reductions where only a few circuits need to be added or removed. The play button provides access to a tutorial video on this topic. Click OK to validate the information and close the window. Creating a tray cross-section. In a tray network, a cross-section represents a specific point where the tray width must be defined due to changes in the installed conductors. To create a new tray cross-section, select Queries on the main menu, then Cable Trays and Conduits, and from the submenu choose Capture. Alternatively, click the CT conduit icon on the toolbar. This displays a grid in which each record represents a tray or conduit cross-section. You may add, edit, delete, or filter records using the grid toolbar. Click the Add icon to create a new cross-section. This opens the main data entry window. Enter the tray label in the name field. In the Type Combo box, select Cable Tray. Enter the length of this tray in meters. The fill factor will display the default value defined in the Standards section. You may customize the fill factor for this specific tray by selecting the checkbox and entering the maximum allowable electrical fill for the tray or conduit. Select the cable tray type and the material used in its construction. By adding multiple segments, you can model your tray network with as much simplicity or detail as required. The segment type field allows you to define each section of the tray and conduit system. For this example, define the section as straight. Enter the tray side rail height, noting that this dimension is a mechanical consideration based on cable weight and support spacing. If you want the tray size to be selected automatically, based on the installed cables, leave the user selection checkbox unchecked. If you have a predefined tray width, and want the software to calculate the fill based on the installed conductors, select User Selection, and choose the predefined tray width from the combo box. To complete the tray specification, enter the rung spacing in the corresponding field. This is required only for ladder-type trays. If the tray must support additional loads beyond the cable weight, such as pollution buildup, snow, hail, or wind loads, enter this supplemental load in the additional load field. Values must be entered in kilograms per meter. The support span and the total load carried by the tray determine its tray class. Enter the distance between supports along the tray route in meters, and the equivalent in feet. As mentioned earlier, the software automatically determines the tray class based on total load and support spacing. However, in some cases the user may need to force a specific tray class regardless of these variables. To do this, enable the corresponding checkbox, which activates the class field, allowing you to select a fixed tray class. To allow the software to automatically determine the tray class, simply clear the checkbox. Finally, the Notes field allows you to enter a brief description of the tray section under Analysis, if needed. Click OK to validate the information and close the window. If instead of a cable tray you want to create a conduit, click the Add icon on the grid toolbar, which will open the same main data entry window. Enter the conduit label and, in the Type field, select Conduit. Define the conduit length and the fill factor. You will notice that the characteristics section changes to display the conduit-specific parameters. Here, select the conduit type, conduit material, and coating. If you want to define the conduit size and have the application calculate the fill, select the User Selection checkbox to enable the combo box and then select the diameter. If you want the application to automatically select the conduit diameter, leave this checkbox unchecked. If required, enter notes to complement the conduit information. Click OK to validate the information and close the window. When you create a new conduit or cable tray, it is added as a new record in the grid. You can manage these records using the options on the toolbar. Note that in the left-hand column there is a conduit icon and a tray icon. When a check mark appears on these icons, it indicates that the conduit or tray has circuits assigned for sizing. Assigning circuits to trays and conduits. Now it is time to select the conduit diameter or tray width. To do this, select Views from the main menu, then Cable Trays and Conduits, and finally, Circuit Allocation. Alternatively, you may click directly on the conductor allocation icon on the toolbar. This opens the window used to place circuits in conduits and trays for sizing. Let us become familiar with this window. It is divided into 4 sections. Tray/conduit section. This section lists the names of all trays and conduits entered in the cable tray and conduit section. Each tray or conduit name is preceded by an icon. This icon displays a green check mark when the tray or conduit has been assigned to the project area and circuits have been associated with it. This section includes a context menu for managing tray or conduit segments, which is accessed by right-clicking. Project Area. This area displays the trays and conduits included in the analysis. Here, trays and conduits are added in order to assign circuits to them. Once circuits are assigned, the calculation results are displayed in the table columns. These results include the selected conduit diameter or tray width, fill percentage, allowable fill percentage per electrical code, e-fill, physical fill percentage, and the remaining available percentage up to the maximum code allowed fill. The table also displays the total number of conductors, the type of Raceway, and the tray class. This section also includes a context menu for managing trays and conduits, accessible by right-clicking. Circuits Area. This area displays the circuits available to be assigned to a tray or conduit. The listed circuits are those entered and calculated using the conductor selection module, and several key characteristics are shown, such as cable type, voltage, and length. Each circuit can be expanded to display the individual phase conductors grouped into phase and neutral sets. The table also shows the conductor size, phase identification, diameter, and a hyperlink that displays the conductor description. This section includes a context menu for circuit management, accessed by right-clicking. Installed in Area. The Installed in Area lists all trays or conduits through which the conductors of the selected circuits are installed. When a conductor set is selected in the circuit list, this area shows the names or tags of the segments where the conductor set is installed. Tray Sizing Process. Let us begin with a tray sizing process. In the project area, select the location where you want to insert the new tray. This can be at the project level or nested within another tray. Select the first element in the tree, which is the project name. Next, select the tray label you want to analyze from the conduit/tray list. When you click it, the item will be highlighted. Then click the left pointing arrow to assign the tray to the project area. Alternatively, open the context menu with the right mouse button and select Assign to, which will include the previously selected destination, either the main project or beneath an existing tray. The project area functions like a file explorer, using the same hierarchical principles. Trays or conduits can exist at the same level to indicate independent routes, or they can be nested to indicate mechanical connections. Conduits hierarchically dependent on a tray represent tray drops, used to route circuits from the tray down to the loads. Once the tray appears in the project area, circuits can be associated with it. To assign a circuit to a tray, ensure that the tray is highlighted in the project area. Then select the circuit from the circuits area below. When a circuit label is selected, the entire row is highlighted to emphasize the circuit information. Click the upward pointing arrow located on the left side menu, or open the context menu with the right mouse button and select Assign to. This will include the previously selected destination, for example, assign circuit to tray 01 CT01. After completing this action using either method, the circuit will appear listed beneath the tray in the project area, indicating that the circuit is installed in that tray. Notice that once the circuit is assigned, the tray fields in the project area are updated to display the selected tray width, fill percentage, and available width. You will also see the total number of conductors, the total weight of the installed conductors, and the tray class. Let us repeat the circuit assignment process using a different method. Select the tray in the project area. Then select the circuit to be assigned in the circuits list. Right-click and, while holding the mouse button, drag the circuit tag onto the tray tag or name. When the tray name is highlighted, release the mouse button. You will see the circuit label appear beneath the tray. At the same time, the cable tray information in the project area is automatically updated. Also notice that the cable tray icon now appears in the Raceways list with a green check mark. This check mark indicates that the tray now has circuits assigned to it. Now let's add a conduit using the same assignment process. At this point, we need to define whether the tray and the conduit are interconnected. Let's assume the conduit is a branch from the tray, used to route the circuit down to the load. To represent this dependency, select the cable tray in the project area, then select the conduit from the Raceways list. Click the left arrow, and you'll see that the conduit is now hierarchically linked to the tray. This represents a mechanical connection, or a tray drop. Next, assign the circuit to the conduit. Select the conduit icon in the project area. When it is highlighted, choose the circuit that will branch from the tray through the conduit. Then click the up arrow. The circuit will now appear under the conduit in the project area. In the upper left section, you'll see the selected conduit diameter, the electrical fill percentage, the available area, and the number of conductors installed in the conduit. If you want to place trays or conduits without any mechanical dependency, select the project label at the top of the project area and assign the tray or conduit as before. This will place them at the same hierarchical level, indicating that they are not mechanically connected. To make the project easier to understand, trays and conduits can be collapsed or expanded. Simply right-click to open the context menu and choose to expand or collapse a single level or the entire structure. Keep in mind that when a circuit is assigned to a tray, all conductors belonging to that circuit are moved together. In some cases, the conductor dimensions may exceed the tray width, making it necessary to move conductors from one tray to another. To do this, expand the circuit by double-clicking its name, or by clicking the plus sign next to it. This displays the conductor sets, grouped by phases and neutrals. To move a conductor set, right-click it, hold the mouse button, and drag it to the destination tray. When the destination tray is highlighted, release the mouse button. Only complete conductor sets can be moved. Individual phases or neutrals cannot be relocated, since that would violate code requirements. When you select a conductor set in the circuit section, the installed in list will show all trays and conduits where that set is installed. At the bottom of the list, you'll also see the total routed length. If this total length exceeds the conductor length used for sizing, the value appears in red, indicating that the conductor data should be reviewed. If it appears in black, the routing length is within acceptable limits. For a better understanding of the conductor layout inside a cable tray or conduit, click the tray-shaped icon, located on each record line. This option allows you to view an image of the conductors assigned to the tray, a list showing the tray characteristics, and a list with the main characteristics of the conductors. This window has its own toolbar, which allows you to go to the first tray view, go to the previous view, go to the next view, go to the last tray view, copy the image to the clipboard, export the list of cables assigned to the tray to an Excel file, export the image of the tray cross-section. The label displays the zoom percentage applied to the image. To zoom in or out, press the Control key and scroll the mouse wheel over the image. After the Close button, you will find a checkbox that allows you to define whether the first 4 navigation icons will move only through first-level trays and conduits, or also navigate through nested trays and conduits. The sections of this window are resizable, making it easier to analyze the information. Note that the conductor type, number of phases, wires, conductor layout, and spacing from other circuits are defined for each circuit in the conductor selection module. This ensures data consistency, since the installation conditions used to select a conductor must be the same conditions used to size the cable tray. To modify the circuit layout, edit the circuit data in the conductor selection module. Click the Close button to hide this window. For conduits, this window displays the conductor layout inside the conduit in the same way. When the number of conductors exceeds the code-allowed fill percentage, or when the conductors exceed the physical cross-sectional area of the conduit, a separate area will be displayed showing the excess conductors. Click the Close button to hide this window. An important advantage of Sizer Electric is that when load data is updated in the conductor selection module, and this change affects conductor size, the tray width or conduit diameter is updated automatically. This saves time and ensures consistent design data throughout the project. These are the basic functions of the conductor assignment module. You can now generate tabular reports for all trays and conduits, as well as the circuits assigned to them. From the main menu, select Reports, then Conduits and Cable Trays. Here you'll find several available reports, including Raceway reports, cable tray reports, circuit assignment reports, and circuit routing reports. The Circuit Routing with Reels report also links each circuit route to the reel from which the conductor can be supplied. Select the report that best fits your needs. You can apply filters and customize the report header, then click OK to generate the report. These are the basic steps for using the cable tray and conduit selection module in Sizer Electric. For more detailed information, please refer to the user manual or the help files available from the main menu. Remember, you can access context-sensitive help at any time by pressing F1. Thank you for watching. We also recommend viewing the companion videos on conductor selection, conductor specifications, and grounding grid design to gain a complete understanding of Sizer Electric.